Well, you finally made it to your last proof, and so let's go here and look at our diagram. We see a familiar setup, triangles that share a side, which may benefit us. And we have two pieces of given information. We are told that D is the midpoint of AC. And remember that midpoint is directly in between two other points. So it's the halfway of a segment. And we have that two angles are congruent. We're told that angles ADB and CDB are congruent to each other. And so since that's part of our given information, let's go ahead and show that angle ADB here and CDB here. Okay. So we've had our given information shown. Maybe we start using the other piece of our given information, this idea that we have a midpoint. And it's the midpoint of segment AC. And so here's point D. To be a midpoint, remember that means that D is directly in the middle of A to C, and C. And so that means that the distance from A to D is the same as the distance from D to C. And so because we have this word midpoint, we're able to use our diagram to realize that segment AD must be congruent to segment DC or CD, whichever way you want to list it. And that is simply because we had the word midpoint to tip us off. So this is definition of midpoint. And that gives us two pieces of information as congruent. And we need just one more in order to say that the two triangles are congruent. So there must be a guarantee now because we've used all of our given information. And again, just one last time, we basically have two guarantees here. Either vertical angles are congruent or there's a shared side. In this case, both triangles use segment BD as one of their sides. And so we can say that segment BD for the left triangle is congruent to segment BD for the right triangle. And that was our reason of reflexive property. So now that we've marked these three pieces of information, why are the triangles congruent? And that would be our theorem of side angle side. And again, now that we know the triangles are congruent, why would other parts be congruent? Well, remember that's the definition of triangles being congruent. So let's look here. What is it we're going to put down here? Are we going to put a pair of angles or a pair of sides? Well, we look at our proof statement, this last statement here. We're supposed to show that triangle ABC is isosceles. And if you think about it, if the big triangle ABC is going to be isosceles, it's probably going to be that this segment AB is congruent to this segment BC. Because if you look at the big triangle, if those two segments are the same, then we have an isosceles triangle. And so what we're supposed to say here is that segment AB is congruent to segment BC. And we see that in our congruent statement. AB is listed first, CB is listed first, so we know that those two segments are congruent to each other. And because we were able to show that, we've essentially shown that the triangle is isosceles, and that's all we have to say. That is the definition of an isosceles triangle. To have two or more sides congruent.